In this video, I'd like to show you how we build Marlowe programs in Haskell. I'll do that by choosing an example, and you see here on the menu bar at the top, there's a menu Open Example, and we have a collection of example files, and those are in different languages. Let's take a look at the first example, which is an escrow contract, where a third party holds and regulates payments of the funds. So let's take a look at that. We'll open that in Haskell. Now what you see here is a header with some information. We import language.marlowe, and the main program is something that takes a contract, which is a Marlowe contract, and expresses it, turns that expression into pure Marlowe. So everything above here is boilerplate, and what we see below the line is actually how we build the contract. So what we have to do is define something contract, with a small c, of type big C contract, which is the type of Marlowe programs. And let's look how we do this. This is just one way of doing it, but what I'm doing here is I've defined the name contract, and this is at the top level, it's a when, which is waiting for Alice to deposit in her account, in the contract, price worth of Lovelace. And when that has been done, it moves into the inner contract. Otherwise, after a timeout of slot 10, it will close. So what we can see here was we're using the structure. Ada is a definition in Marlowe. It's just the definition of the particular token. But price is a particular value, and inner is another contract. So you can see here inner is defined. And then in the inner case, what we have is we wait for Alice to make a choice, and then we wait for Bob to make a choice. And then on the basis of those choices, if they're the same, we have agreement. If not, we arbitrate. And again, we define the contract's agreement and arbitrate further down in the file. So what you see here is instead of having a single monolithic contract, what we see instead is we're defining parts of the contract and putting them together using constructs in Haskell. Now, to check that we're doing that properly, we have the button here on the top right-hand corner to compile. And what compilation will do is that's the process of turning this Haskell description of a contract into a pure Marlowe contract. And you see the contract here in this overlay pane. You can see it's rather more long-winded. You can see still that it is saying wait for a deposit from Alice, and then wait for a choice from Alice, wait for a choice from Bob, and so on. So the structure is there, but none of the interior components is named. Now there are two things we can do once we've got this contract in successfully compiled. Well, three things we can do. One is we can carry on developing the contract in the Haskell editor. We can just hide that and carry on editing. But we have two more choices available now. We can either send the contract to the simulator, so we can interact with it, and we'll see that in a later video, or we can send it to a Blockly representation. Let's just click on that briefly now. So what we see here is in Blockly, we see a rendering of the contracts that we have just written. And so you can see, as it say, it waits for a deposit by Alice of 450 Ada, and then it waits for a choice by Alice between 0 and 1, then a choice by Bob between 0 and 1. If the value by Alice and the value by Bob are equal, then we do what's in this part of the contract. Otherwise, we wait for a choice from Carol, who will arbitrate. So you can see we're seeing this visual representation, but we also have we have the simulator representation here, and we can also go back. We can go back to look at the Haskell source. So we've written the Haskell, we turn it into Marlowe, we can view it visually, we can view it in the simulator, but we can go back and carry on developing the Haskell. So I'll stop there, and we'll take a look next at how we do a similar thing in JavaScript.